right, let's take a look at our lesson on arithmetic sequences and series. So these are a special kind. Last lesson we talked about arithmetic, geometric, and neither. So let's kind of dig into more depth on the arithmetic. Okay, so if we have terms that are, next to each other, so we want to figure out how to find D. And what is D? D is called the common difference. The common difference. And how do you find the common difference? Or what is it? What is a common difference? It's a number that you would add or subtract, which that's the number D, over and over to get the next term, to get the next terms. Okay, so that's what a common difference is. So if we don't have numbers that are in sequence, so typically in this particular case, to find D, this is the simplest case, we can practice that with this example. So we would take a sub n minus a sub n minus 1. So basically we take the second term minus the first term, and that would give us our common difference. So common difference would be the second term minus the first term, which would be 7. Well, what if we have numbers that aren't right next to each other in sequence like that? How would we find our D? Well, what we would do is, this is a little formula that, you don't have to memorize, but it would be very helpful if you knew it. So this is an example using the little formula. What you would do is let's say you have the 8th term and the 12th term. How would you find the common difference if you had the 8th term and the 12th term? Well, we would take the 12th term and we would subtract the 8th term from it, kind of like, the second term minus the first term, but it's basically the 12th term minus the 8th term. And then on the bottom, we would just subtract the term numbers, the 12th term minus the 8th term, and that would give us, after we simplify, that would give us our common difference. Okay, so that's two ways to find the common difference, either if the terms are right in sequence, like on this first example, or if they're not, that will help you find the common difference. Okay, so let's look at the other formula here. So this formula is the formula to write the nth term. Nth term, we've talked about that before. The nth term is a formula. So what is the nth term? It is a formula to find terms. So if I wanted the 5th term, I would plug a 5 in for n. That would give me the 5th term. So let's kind of talk about each one of these numbers. This is basically the term number. That's the term number. The first term, second term, third term, etc. This is the first term. Okay, very good. This is also the term number. And then D, we just talked about D. D is the common difference. Okay, so those are all the parts of that formula. Okay, so let's practice using that formula. We'll go back to this first example. We've already started it. We've already found D. They want us to find the 12th term. Okay, we have, this is term number 1, term number 2, term number 3, and our common difference is D. So, that's the 12th term. You could just keep adding 7 to get to the 12th term, but we really don't want to do it that way. What if you need the 100th term? That would just not be very good to have to do this 100 times. So instead, let's write a formula. Let's write the formula for it. So we want to find a sub 12. We want the 12th term. Our first term is 9 plus, and we want the 12th term, so that's n minus 1 times D is our common difference of 7. And so that would be, let's see, the 12th term would be 9 plus, let's see, 12 minus 1 is 11. 11 times 7 is 77. So our 12th term, using this formula, is 86. Okay, great. So on the next one, we want the equation for the nth term. Nth term, that sounds weird. Okay, nth term. Basically, they want the equation with the n in it. So we just need the general equation. That's what we want, is the general equation. All right, so, okay, they give us a 5th term, and they give us our common difference. Okay, so we need to get to, in order to write our formula, the only thing that we don't have is our 1st term. So how are we going to find our 1st term? Okay, let's think about that. So if I want the 1st term, so I have the 5th term, 19 is the 5th term. Okay, I want a sub 1, I don't have it, we're just using the formula from up there. That 19 is the 5th term, and our common difference is 6. Okay, so now our job is to simply combine like terms and solve for a1. We need our 1st term. So 19 would be a sub 1 plus, let's see, 5 minus 1 is 4. 6 times 4 is 24. So our 1st term is going to be -5. All right, so we're working on the equation. We're going to write the equation for the nth term. So here we go. We've got a sub n equals -5 is our 1st term plus n minus 1 times 6. Now, since they're asking for the general equation and not just a term, we probably should clean it up a bit, you know, distribute, combine like terms, get it in a better form. So let's work on that. Let's distribute and combine like terms. So a sub n would be -5, let's see, plus 6n minus 6. So our general equation would be a sub n equals, let's see, -5 minus 6 is a -11 plus 6n. And there's our general equation in simplest form. You know, we like simplest form. Okay, so let's go to our second page and get a little bit more. These were sequences. This is a sequence. This is the formula for finding an arithmetic sequence. Okay, that's what that does. So now let's move on to series. How are we going to do with series? So first, what is a series? A series is formed when the terms of the sequence are added together. The terms of the sequence are added together. That's a series. An arithmetic series is the indicated sum of the terms in the sequence. So, and this is called, the first n terms is called the partial sum. So this is a formula right here for partial sum. Okay, this n would tell me which sum I wanted. Okay, so this is the number of terms. So that m is the number of terms. Okay, this is also number of terms. Okay, this is the first term. And this is the last term. And using this formula, we would be able to find the sum. Okay, so let's see a different kinds, a variety of things to do. So when finding the partial sum, then we also may need information to find the last term, which means we're probably going to need this formula up here, this sequence formula, so we could find a specific term. Okay, so let's see what we're faced with here. So the first one is find the sum of the first 40 terms. Okay, that's kind of crazy. So let's start our formula. So S sub 40 equals in 40 times, let's see, I have my first term, that is a 2, plus, I don't have my last term, we're going to have to find that, over 2. Okay, so we have our job now, our unknown. This is our unknown right here. We don't know what our 40th term. So this is going to, what we have to put here is the 40th term, right? Because the formula asks for the first term and the last term divided by 2 times the number of terms. Okay, great. So to find the 40th term, it would be really to our advantage is to use our little formula for, let's just write that down here. So the formula for a sequence, a sub n equals a sub 1 plus n minus 1 times d. Okay, great. So let's work on the 40th term. So a sub 40 would be, our first term is 2 plus 40 minus 1 times, let's see what our common difference is. 4 minus 2 is 2, 6 minus 4 is 2, so d is 2. Okay, so let's put this here. So let's see, 2 plus, let's see, 40 minus 1, 39 times 2. So our 40th term is 80. Okay, so let's put that in our formula, 80. And then we put this in our calculator. So let's see, 80 plus 2 is 82. 82 divided by 2, so we have 41. 41 times 40 is 1,640. So that's our 40th partial sum. Okay, great. Here we go. Let's practice another one. So let's start writing our formula. Ooh, we don't know how many terms are here, do we? We have our first term and we have our last term, but we don't know how many terms. Well, let's again use our sequence formula. So we don't know how many terms. Let's just highlight this sequence formula. We're just going to use this one again. Okay. So let's see. So 180 is the last term. Okay, we know the first term is 12 plus, we don't know that term number, right? That's what we want. We want to know which term number is 180. And then we're supposed to multiply by the common difference. Let's see, what would the common difference be? It'd be 19 minus 12, which is what, 7. Okay, so we multiply by 7. So let's do that. So let's see. So let's subtract 12 from 180, and that gives us 168. And then I've got 7n minus 7. Okay, so let's add the 7 over. So 168 plus 7 is 175. And n is 25. Now the n's, we talked about this earlier, the n's or the term numbers are always going to be integers that are positive. You're never going to have a fraction for an n. You're never going to have like a negative number. They're always going to be positive integers. Okay, so that's just a fact. So now we want to find the 25th sum, and we're going to use our little formula. So 25 times the first term, which is 12, plus the last term, which is 180 over 2. Again, we would use our calculators to find this. And so that gives me, after I put it in my calculator, it'd be 2,400. The 25th partial sum is 2,400. All right, one more. Let's see, the first 3 terms of the arithmetic series in which a sub 1 is 7. And they give us the sum. Well, that's strange. Okay, so they give us the sum. Let's try to use this sum formula. So that if the sum is 430, 430 equals, we don't know n, right? We don't know how many terms there are. And they want us to find the first 3. So we don't know how many there are. So we just need to solve for n so we can tell how many there are, so we know what our first 3 terms are going to be. Okay, so let's see. So our first term is 7, our last term is 79, Okay, great. We're going to be able to find n. So 430 equals n times, let's see, 7 plus 79 divided by 2. Again, we put that in our calculator. That's what 86 halves. We solve for n, and n is going to be 10. Right, 86 halves would be what, 43? And 430 divided by 43 is 10. Okay, so let's write our sequence formula out. So our first term is 7 plus n minus 1, and our common difference, let's see, what would our common difference be? We don't know, so we're going to have to figure that out. Okay, so let's try, if there are 10 terms, if 79 is the 10th term, so if 79 is the 10th term, then we can find D by solving for D. Okay, so let's see, we move the 7 over, we get 72 equals 9D, so D is 8. Okay, great. So if my first term is 7, then I add 8 to 7 and I get 15, and then I add 15 to 7 and then I get 23, and now I have the first 3 terms.